Hi everyone, today we're going to be talking about operations with polynomials. Our objectives for today are that students will be able to multiply, divide, and simplify monomials and expressions involving powers, and you'll be able to add, subtract, and multiply polynomials. Let's get started. As we begin, let's define monomial. So a monomial is a number, variable, or product of numbers and variables. So what we need to remember about monomial is that we see the prefix mono, which means one. So we have a monomial is a single term. So for example, 4 could be a monomial. 7x is a monomial. 3x squared is a monomial because they're all single terms. You could also say 4x to the third power. That's a monomial. So anytime we have a single term, that's a monomial. And then we want to use what we call exponent rules to help us simplify monomial expressions. So we've got 5 different rules here. The first one is the product rule. So I'm going to zoom in here on our table to help us fill this in a little easier. So the product rule says if we have the same base and we have exponents, so a meaning that's the same base, so a to the m power times a to the n power, what we do is we add the exponents together. So an example of this, if we have x squared times x to the 7th, what this would equal x to the 9th because we just add the exponents together. 2 plus 7 gives us x to the 9th. Then the power rule. The power rule tells us is that if we have an exponent that looks like this and it's inside the parentheses, so say we have a to the m power and we raise it to another power, how we would rewrite this is we would say a to the m times n. So we multiply the exponents together. So for example, if we had x squared to the 7th power, we would multiply the exponents together. So 2 times 7, and that would give us x to the 14th power. All right, now the quotient rule. So quotient meaning dividing. So if we're dividing, say we have a to the m power divided by a to the n power, what we would do is we would subtract the exponents. So we would simplify this by saying a to the m minus n power. So for example, if we had x to the 7th over x squared, we would simplify this by subtracting the exponents. So 7 minus 2 gives us 5. The negative exponent rule. So anytime we have a negative exponent, so a to the negative m power, what we do is we rewrite it as 1 over a to the positive m power. So basically we take the exponent, make it positive, and put it in the denominator. So for example, if we had x to the negative 2 power, we would rewrite this as 1 over x squared. And last but not least, the zero exponent rule. So if we have anything to the 0 power, it always equals 1. All right, the exception to this is that we cannot have 0 to the 0 power. All right, 0 to the 0 power would just be undefined at this point. All right, so that is the exception to this rule. So an example, if we said 7x squared to the 0 power, anything to the 0 power always equals 1. All right, and last but not least, remember that when you're adding or subtracting monomials, we always want to combine like terms. All right, so let's use what we just learned and go through some examples. All right, so let's do numbers 1 and 3, a few examples. So what we want to do, starting with number 1. All right, if we're starting with number 1, first thing we want to do is we want to recognize that we're multiplying here. So the first thing we'd want to do is multiply the numbers together. So 5 times negative 7 gives us negative 35. Then we would want to multiply the x squared and the x to the 6th power together. Now this would be using the product rule because x is the same base, so we would add the exponents together. So to simplify x squared times x to the 6th, that would give us x to the 8th power. And you're done. All right, moving on to example number 3. So the first thing we want to do with example number 3 is take this right here and simplify it before we subtract 10m to the 4th and to the 3rd, all right? Always simplify anything with division bars first. So first thing you want to do is we want to simplify the 54 divided by 3. So 54 divided by 3 gives us 18. Then we want to simplify the m's together. So m to the 6th divided by m squared, we would subtract the exponents. So we end up with m to the 4th. And then n to the 4th divided by n. And this is just n to the 1st power. So anytime you just have a variable, there's an invisible to the 1 power there. All right, so we would do 4 minus 1, and that would give us n to the 3rd. All right, then we just copy down what we see above. Bring down the 10m to the 4th, n to the 3rd. All right, now what I want you guys to recognize is that the first term is a number, m to the 4th, n to the 3rd. The second term is a number, m to the 4th, n to the 3rd. So therefore, these are like terms. So just like if this was 18x minus 10x, that would give us 8x. In the same way, it's 18 m to the 4th, n to the 3rd, minus 10 m to the 4th, n to the 3rd. So we would just subtract 18 minus 10, and that would give us 8, and we would just say m to the 4th, n to the 3rd. All right, because they're like terms, so we're just subtracting the coefficients in front. All right, if you have any questions on 1 or 3, call me over. Otherwise, let's keep going. All right, so numbers 5 and number 7. So first, let's do number 5. First thing we want to do is distribute the squared to every term inside the parentheses. All right, so we would have to do 2/3 squared, r squared, and 7s squared. Okay, so we would do 2/3 times 2/3, which would give us 4/9, and then times r squared times s to the 7th squared. All right, and then we're just bringing down what's in the second parentheses, and we can just drop the parentheses. So we've got times 1/6 times r to the 3rd times s, and we can put an invisible 1 up there because we know it's s to the 1 power. So that'll help us when we're combining like terms. All right, then we want to keep simplifying. So this right here is going to simplify to r to the 4th. This right here is going to simplify to s to the 14th because we multiply those exponents together. Then we've got 4/9 here, and keep bringing everything else down. Now we just want to combine like terms. So we would do 4/9 times 1/6, and that will give us, let me get some more space here. Oh well, I'll just keep writing underneath. All right, so 4/9 times 1/6, we multiply straight across, and we get 4/54. Then we would want to do the r's together, and we would be adding the exponents here because this is product rule. So r to the 7th power, and then the s's together would give us s to the 15th power. Now 4/54 we can simplify, so we can divide top and bottom by 2, and we can get 2/27, r to the 7th, s to the 15th. And that would be our final answer. Then moving on to number 7. Sorry, it's kind of overlapping here, but that's okay. All right, so number 7, we would want to do 15 and 24. We want to simplify that. We can't really divide it, but we can divide top and bottom by 3 to simplify it. So we end up with 5/8. Then we want to simplify the x's together. So x to the 10th divided by x to the 12th will give us x to the -2 power. And then simplifying the y's, y to the 4th divided by y to the 3rd, subtract the exponents, and we end up with just y, or y to the 1 power. All right, now the key thing with this one is we have to recognize that we have a negative exponent here. So negative exponent, we would rewrite this as 1/x squared. All right, and bring everything else down, times y. All right, and times y is the same thing as y/1. So now we see that this up here is our numerator and this down here is our denominator. So if we wanted to rewrite our final answer, we would write it as 5y/8x squared. and we simplified this monomial. All right, so now we're going to be talking about polynomials. So a polynomial is the sum or difference of many monomials. So poly meaning many. So anytime we see a polynomial, it's going to either be adding or subtracting monomials together. So the highest degree of any polynomial is called the degree of the polynomial. And standard form of a polynomial means that we always write with exponents in descending order. All right, so we always want to write them with exponents in descending order. So meaning from greatest to least. All right, also we want to write them in alphabetical order too. All right, alphabetical, that's a hard word to spell. So that's just another note in standard form. So some examples here, we've got 10, 11, and 12. So looking at number 10, we want to look for the biggest exponent because they're all k's, so we don't have to worry about alphabetical. So we look for the highest exponent, and that would be this term right here. So negative k to the fifth would come first. Then we want to look for the next highest exponent, so negative 3k to the third. So that's what we would write next. So descending order means from the biggest exponent to the smallest exponent. All right, so from greatest exponent to least exponent. Then the next biggest exponent would be this one right here. So then we would say plus 1/4 k squared. And then need a little more space here. The next biggest exponent would be a single k, so plus 8k. And then last but not least, minus 1. Number 11, we've got a's and b's, so we want to look for our a's first and look for the highest exponent of a's, so that would be this one right here. So we start out with 4a to the third. Then the next biggest a would be this one right here, and it also has b's, but that's okay. So then we would say plus 18a squared b squared. Then we would want to say 7ab because that single a still comes before the b squared, all right, because alphabetical order first. Then we would say minus b squared. So now what I want you guys to do is pause your video real quick, and I want you to try number 12 on your own. All right, so go ahead and try number 12. When you come back, I'll have the answer written on your screen, and we'll go through it together. So go ahead and pause your video now. All right, so here's the answer to number 12. Remember, we want to go alphabetical order, so look at your x's first. The highest degree of x would be this monomial, so we write it first. Then the next highest degree of x. Then the next highest degree of x, and even though it's got a y squared, all right, this single x becomes before the y to the fourth. All right, then we would write minus y to the fourth plus our constant. If you have any questions on this, be sure to call me over so I can help you. Otherwise, let's move on. All right, so classifying polynomials. Polynomials are classified by their degree, so by the highest exponent, and by the number of terms. So what we're going to do is we're going to fill in these charts that will help us be able to classify the polynomials. So these charts are super important. I starred this slide. This is a super important one. I highly, highly recommend that you memorize these two charts. All right, so if it's a 0-degree polynomial, that's called a constant polynomial. A single degree polynomial, so say 5x, just 1x, that's linear. All right, so constant's just a number. A single variable, all right, single degree would be linear. X squared, so a second degree polynomial, that's quadratic. X to the third, if the highest degree is to the third power, that would be a cubic polynomial. If the highest degree is x to the fourth or y to the fourth, all right, so 4 is the highest degree, we call that a quartic function. And if the highest degree is 5, so it's a 5th degree polynomial or x to the 5th, we call that a quintic polynomial. Then if we're classifying by the number of terms, so how many terms does it have? If it's a single term, we already went over that, we call that a monomial. If there's two terms, we call that a binomial. Binomial, like bicycle has two wheels, binomial has two terms. All right, if it has three terms, we call that a trinomial. All right, tri means three, like a triangle has three sides. Trinomial has three terms. And anything that has four or more terms, we just call it a polynomial. All right, so 13 through 20, or 13 through 18, we're just classifying them by their degree and by the number of terms. So for example, number 13, this is a linear polynomial, all right, because the highest degree is x to the first power, so that's linear. And it's a binomial because there's two terms. It's something plus or minus something, two terms. Negative 3x is one term, 1 is the other. All right, number 14, the highest degree is 5. So this is a quintic polynomial. So it's quintic, and there's three terms, so it's quintic trinomial. 15, this is just a constant because it's a number, no variable, no degree. It's a 0 degree polynomial. All right, so we call this a constant monomial, single term. All right, I want you guys to try to do 16, 17, and 18 on your own. Go ahead and try to do these. When you come back, I'll have the answer written on your screen, and we will go through it together. So go ahead and try to do 16, 17, and 18. All right, so 16 is cubic because the highest degree is 3, and there's 1, 2, 3, 4 terms, so it's a polynomial. 17, the highest degree is x squared, so 2 is the highest degree, so it's quadratic, and there's 1, 2, 3 terms, so it's a trinomial. 18, it's a single term, so we know it's a monomial, and the highest degree is 4, so it's a quartic monomial. If you have any questions on this, call me over. Otherwise, let's keep going. All right, so 19 and 20, there's many different answers you could have for these, so I just want to give you one example. So if we wanted to give an example of a cubic binomial, all right, we can say 3/5 x to the third plus 7/6 x. That would be a cubic binomial because the highest degree is 3 and there's two terms. Giving an example of a linear monomial, negative 5x, all right, or you could just say x. X would be a linear monomial. It's a single term, monomial, and degree of 1, okay? So these are two examples. You could have come up with anything, but I just wanted to give you two examples. All right, so now let's talk about adding and subtracting polynomials. So when we're adding and subtracting polynomials, we want to just combine like terms. We want to watch out for subtraction problems, so you want to be sure to distribute the subtraction to all the terms in the second parentheses. Then we always want to be sure to write our answer in standard form, so in descending order according to the exponents and in alphabetical order. All right, so let's do number one as an example. So first thing we want to do, we can just drop all the parentheses because it's addition. So rewrite it as 3x squared plus 11x plus 4 minus 5x plus x squared minus 13. Now we just want to combine like terms. So look for the highest degree first. We've got 3x squared plus x squared. That's going to give us 4x squared. Then we've got 11x minus 5x. That's going to give us 6x. And then last but not least, 4 minus 13 is going to give us negative 9. And there's our solution. It's written in standard form, and we're done. All right, number 3, this is a subtraction problem where we have to be careful and we have to distribute the subtraction to every term in the second parentheses. So we rewrite the first one exactly how it is. And then we want to say minus 2k squared minus 2k minus 17. Then we're just combining like terms, so look for the highest degree. 5k to the third. There's no other k to the thirds, so that's going to be our first one. Then we want to look for the k-squareds. So negative 2k squared minus 2k squared is going to give us negative 4k squared. Then plus 2k minus 2k, those are going to cancel each other out, and then you're just left with minus 17. So there's your solution. It's written in standard form in order from highest exponent, which is the k to the third, to the constant, and you're done. All right, for time's sake, we're going to skip number 5, and we're going to move on to multiplying polynomials. So first thing we want to do when we're multiplying polynomials is to either distribute or FOIL. So if we have a monomial times a binomial, trinomial, or polynomial, be sure to distribute. And anytime you have binomial times binomial or bigger, remember to FOIL. Then we want to combine like terms and write our always write our answer in standard form. So descending order of the exponents. So first thing we want to do in this problem, number 7, let's start with this binomial times this binomial. So we need to FOIL that out. So 2x times 4 gives us 8x. Then 2x minus 9x gives us negative 18x squared. Inner gives us plus 4. And then last, minus 9x. And then over here, we want to be sure to distribute the negative 2x to both terms on that side. So we end up with negative 6x squared minus 22x. Now we're just combining like terms. So look for those x squareds first. That's our highest degree. So negative 18x minus 6x, negative 18x squared minus 6x squared gives us negative 24x squared. Then we want to look for all the x's. So we've got 8x minus 9x minus 22x. So 8x minus 9x gives us negative 1x minus 22x, negative 23x. And then last but not least, our constants, we just have this plus 4, so we can't forget about that. Add it on to the end. And there's our simplified polynomial. All right? If you have any questions on this, please call me over so I can help you. Otherwise, let's keep going. All right, so number 9. Number 9, we first have to rewrite this, all right? So we can't just do 2c to the third plus 5d to the third. You cannot do that, all right? That is a big no-no. What we need to do is rewrite this as 2c plus 5d times 2c plus 5d times 2c plus 5d. All right, and then we've got to FOIL it out little by little. So start by FOILing the first two out. So we get, 4c squared plus 10cd plus 10cd plus 25d squared. And if we simplify this out, we get 4c squared plus 20cd plus 25d squared. And then we've got to bring down that last 2c plus 5d. All right. Now what we want to do is we want to distribute this out. So we want to do 2c times every term in the first one. And when we do that, we get 2c times 4c squared gives us 8c to the third. Then 2c times 20cd gives us plus 40c squared d. Then we get 50c d squared. Okay? Then what we want to do is we want to multiply 5d to every term in the first parenthesis. So 5d times 4c squared is going to give us 20c squared d. All right, and that's positive. Then 20cd times 5d is going to give us 100c d squared. And then 25d squared times 5d is going to give us 125d to the third. All right, now as you can see, I lined up all the like terms, so it'll make it easy to combine like terms. So we end up with 8c squared plus 60c squared d plus 150c d squared plus 125d to the third. All right, and that's our final answer. So remember, you got to FOIL/distribute when we're multiplying binomials together. All right, so why don't you guys try to do number 11 on your own. Remember to distribute every term to each term in the other parentheses. So here you're essentially FOILing, but you're doing 3 terms. So what you're going to want to do is you're going to want to say x squared to this term, times this term, times this term. Then you're going to want to say 6x to that term, to that term, to that term. And then last but not least, 7 times this, this, and this. So you're essentially triple distributing, and be sure to line up those like terms so it's easy to combine in the end. So go ahead and give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. Alright, so your final answer should be negative x to the fourth minus 15x to the third minus 51x squared plus 39x plus 28. Alright, so if you didn't get this answer, be sure to check for silly mistakes. Okay, you want to distribute x squared, multiply every term in the second. Then 6x, multiply to every term, and you get this. Then negative 7, multiply to every term, and you should have gotten this right here. I lined up all the like terms so that it's easy to combine like terms in the end. And this is our final answer. If you have any questions, call me over. Otherwise, let's move on to dividing polynomials by a monomial. Alright, so when we're dividing polynomials by a monomial, first thing we want to do is divide each term in the numerator by the monomial in the denominator. Always write our answer in standard form and rewrite all terms with negative exponents so that they're positive. Okay, we can't have negative exponents. You always have to rewrite them. So, for example, number 13, what we want to do is we want to rewrite it as every term in the numerator divided by the denominator. So we would rewrite this as 9m to the third divided by 3m minus 24m squared divided by 3m. And then we're just simplifying. So in the first one, 9 divided by 3 gives us 3, and m to the third divided by m to the first power, we subtract the exponent, so we get 3m squared. Minus 24 divided by 3 gives us 8, and then m squared divided by m gives us m, because we just subtract the exponents. So there's our final answer. We just divided a polynomial by a monomial. Alright, number 15 looks like a multiplication problem, but it's really a division problem, and let's see why. So what we want to do is we want to rewrite this right here as this negative exponent as a positive exponent. So anytime we have to the negative 1 power, we would want to rewrite this as 1 over 2ab. So what we're saying is we're saying this giant polynomial. Alright, I'm just rewriting it. ab squared plus 2ab times 1, alright, times 1 over 2ab. So what we're saying is this whole thing really is 14a to the fourth, b to the third, minus 20a squared, b squared, plus 2ab. It's all over 2ab. Okay, so when we're multiplying by 1 over something, we can just put it in the denominator, because essentially this is all over 1 as well. So we're just multiplying straight across. Now we would want to rewrite this as every term in the numerator over or divided by the denominator. So we would rewrite this as 14a to the fourth, b to the third, over 2ab minus 20a squared, b squared, over 2ab plus 2ab over 2ab. So here we get 7 a to the third, b squared, minus 10ab plus 1. And that would be our final answer. Alright, last but not least, number 17. I want you guys to try to do this one on your own. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. Alright, so you should have gotten 10x minus 4 plus 3 over x. How did you get that? So first thing we want to do is rewrite this every term in the numerator divided by the denominator. So we rewrite it as this right here. Then simplifying, 30 divided by 3 gives you 10. Subtract the exponents and you get an x. 12 divided by 3 gives you 4. Subtract the exponents and you get x to the 0 power, so it just goes away. Then 9 divided by 3 gives you 3. X to the 1 power divided by x squared gives you x to the negative 1 power. Then we have to rewrite our negative exponent. So what we would do is x to the negative 1 power means we take the x and we move it down to the denominator. The 3 still stays in the numerator, but the x just goes down to the denominator. And that's how we get our final answer. So hopefully you learned a thing or two about operations with polynomials today. If you have any questions, be sure to ask me or ask a friend. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye!